Here are the answers to the 10.3 assignment, so pause the video if you want to look over these answers a little bit more closely. Today we're going to look at graphs of quadratic functions, and we're going to start with what our book calls the standard form for quadratic equations. I would actually disagree with this. This is widely known in the math community as the vertex form of the quadratic equation. This form is found by completing the square for this. This typically is referred to as standard form in all other classes. And this one is really called vertex form. But in your book, it's going to ask you to write things in standard form. So standard form, vertex form, basically same thing. The vertex in this form is found at hk. And notice it says minus h. That means that we take the opposite of whatever we see here, and that's the first part of the vertex. The second part of the vertex is completely normal. It's just that k value. If our a value, a is the number in front of the parentheses, if that is positive, the parabola opens upward. If that a value is negative, the parabola opens down. So we are talking about graphs of parabolas. That's the U-shaped graphs that I'm sure you remember from previous classes. So in our first example, it says to find the vertex and the y-intercept of the quadratic function and sketch a graph. So first we need to identify the vertex. The vertex is the opposite of the number inside with the x, so -3, and then the normal number that's outside, -2. Our vertex is at -3, -2. So you can plot that point. A quadratic function, a parabola, is symmetrical, and that vertex is that middle point. So we can draw a dashed line straight through that vertex. That is known as the axis of symmetry. It's a symmetry line for the parabola. All y-intercepts are points that are on the y-axis. They all have x values of 0. So if they're asking us to find the y-intercept, they're saying, if x is 0, what would the y value be? So all we have to do is plug 0 into here. 0 plus 3 is 3. 3 squared is 9. And 9 minus 2 is 7. So all we are doing is plugging in 0. So you might want to write, to find the y-intercept, plug in 0. So we found that our y-intercept, I'm going to do a different color, our y-intercept is at 0, 2, 3, 4, 5, 6, 7, just barely off of our graph. This is a symmetry line. This y-intercept is 3 units away from the symmetry line, so go 3 units in the other direction, and there's another point on our graph. So I'm going to label this. This is our vertex at -3, -2. This one is our y-intercept, where we plugged in 0 and we got the value 7. And this is simply reflected over that symmetry line. So now we can draw in our parabola. Remember, it's a U shape, not a V shape, so try not to make it pointy. I kind of missed there. Ooh, I am not doing a very good job with this. That's better. And there's our parabola. I would like you to pause the video and try example 2 on your own. It just doesn't have a plus k value. So first step is to find your vertex. If there's no k value, it's just 0. And then find your y-intercept by plugging in 0. Your y-intercept has to be 0, something. So pause the video, try to find your vertex and y-intercept, and plot this graph. So our vertex is at positive 2, 0. It's like there's a plus 0 here. So positive 2, 0, that's right here. And there's a symmetry line through that vertex. To find our y-intercept, you plug in 0, you get 4. So 0, 4. And then reflect that over your symmetry line. You really only need 3 points to draw a parabola. You need the vertex, you need one other point that you can reflect over that symmetry line, and then you've got enough information to draw in your parabola. Okay, example 3, this is what I would consider to be standard form, but the book wants us to write this in the other form so that we can find the vertex and the y-intercept. So right now we have y equals x squared minus 4x plus 7. We can rewrite it in the other form by completing the square. So remember from a few days ago we completed the square. I'm going to start by subtracting 7 on both sides and leave myself a blank, equals x squared minus 4x blank. We have to figure out what to put here that would complete the square. So 2 times what is negative 4? Negative 2. Negative 2 squared is positive 4. So the number that we need to add to complete the square is positive 4. That means that we can factor this into x minus 2 squared. And on the left side, we now have y minus 3. We're going to put this back with the negative 3. We need to add 3 to both sides to get it back to the other side. Y equals x minus 2 squared plus 3. Hold on a second. Sorry for all the beeping and dinging and donging. Okay, now that we have it written in this form, we can figure out what the vertex and the y-intercept is. The vertex is going to be the point 2, 3. Remember, you take the opposite of the number in the parentheses, and this other number is perfectly normal. So we got the point 2, 3. That's our vertex. The y-intercept can be found by plugging in 0. 0 minus 2 is negative 2. Negative 2 squared is 4. 4 plus 3 is 7. Helpful hint, this number, when it's written expanded like this, that number is the y-intercept. That's the one nice thing about that form, is that it tells you the y-intercept. Our vertex gives us the symmetry line, so we need to take that y-intercept and reflect it over, and then we can draw in our parabola. For example 4, there's something a little bit concerning. There's a negative in front of the x squared, so we have to be careful what we do with that negative. So what I'm going to do is, we've got y equals negative 1 times x squared minus 6x plus 10. And what I'm actually going to do is multiply both sides by negative 1 just to get it away from that right side completely. So you can either divide both sides by negative 1 or whatever you want to do, but we're going to end up with negative y equals positive x squared minus 6x plus 10. We basically just multiplied everything by negative 1. So this becomes negative y, positive x squared, negative 6x, positive 10. And we'll fix it later. Okay, first step is to subtract 10 on both sides and leave yourself a blank. Now we need to complete the square. So negative 6 is 2 times negative 3. So we need to do negative 3 squared in this blank. Negative 3 squared is positive 9. That makes our factored form on the right side x minus 3 squared. On the left side, we now have negative y minus 1. Okay, We can add 1 to both sides to make it look better. So negative y equals x minus 3 squared plus 1. But to get rid of this negative in front of the y, we need to divide everything by negative 1. So that will make this negative 1 times the quantity x minus 3 squared minus 1. When you divide everything by negative 1, you're only sticking that negative 1 in front. You're not changing the parentheses. Keep those parentheses solid. Don't mess with those parentheses at all. Okay, so now the equation that we're working with, and I'll write it up here so it's easier to see, is y equals negative x minus 3 squared minus 1. Okay, the vertex is at positive 3, negative 1. The y-intercept, and you can actually look back at the previous version to see what the y-intercept is, but typically to find the y-intercept, you plug in 0 and you see what you get. So 0 minus 3 is negative 3. Negative 3 squared is 9. So we'd have negative 9 minus 1, because you have to apply that negative. Let me write this a different way. We'd have got negative 0 minus 3 squared minus 1. And negative 1 minus 1 is negative 10. So our y-intercept is at 0, negative 10. We have a symmetry line that goes here through that vertex. So we can reflect our y-intercept, 1, 2, 3, 1, 2, 3, here. That negative in front, all it really did was flip this parabola upside down so that the parabola opens downward instead of opening upward. Now you might not have this one in your paper copy of the notes, but that's okay. Another way, instead of completing the square, is to use this formula for the axis of symmetry. The axis of symmetry is opposite of b over 2a. So a is the number in front of the x squared, so our a is 1. B is the number in front of x. C is the number that has no x. So to find your vertex would be at the opposite of b over 2a, comma, something. To get this number, you simply plug whatever you get for the x value in. So opposite of our b would be 4 over 2 times 1. That would be 2. So our vertex would be at 2 something. You'd plug 2 in. 2 squared is 4. 4 times 2 is 8. 4 minus 8 is negative 4. Negative 4 minus 5 is negative 9. So this one has a vertex at 2, negative 9. The nice thing about this is that you don't have to do quite as much work to complete the square. And this last number, that negative 5, that is your y-intercept. So you can grab your y-intercept and reflect it over. And really, we only did this amount of work. That's really not very much work at all. So using that opposite of b over 2a, again, that's opposite of b over 2a, you can find the coordinates for your vertex quickly and easily without having to go through the whole process of completing the square. Okay, so again, I know I don't think that some of you have this slide in your notes, but I want you to try this one on your own. Do opposite of b over 2a, find your vertex, find your y-intercept, and then sketch a little graph on a piece of paper. Play the video when you're done to see if you did it correctly. So I did the opposite of b over 2a and I got 3. That means the vertex is at 3 comma something. You plug in 3 to figure out what that something is. So I plugged in 3 and I got 1. That means the vertex is at 3, 1. There's a symmetry line between, right, going through that. And then your y-intercept is always your c value. So this negative 8 is our y-intercept. We reflect that over, and then we can draw in our parabola. On this assignment, using whatever method you want, whether completing the square or using the opposite of b over 2a, find the vertex for each equation, find the y-intercept, and then graph it.